In this video, we have a word problem that we need to solve, and this word problem represents a system of linear equations. So let's read it, and let's set it up, and let's solve it. Tickets for a concert cost $10 each if you order them online, but you must pay a service charge of $8 per order. The tickets are $12 each if you buy them at the door on the night of the concert. How many tickets must you buy for the costs to be the same? All right, let's make sure we understand. There's two ways to buy tickets. One is online. If you do that, the cost is $12 per ticket, plus an $8 service fee. If you buy them at the door at the night of the concert, they're $12 each. Apparently, at a certain point, it'll cost you the same whether you buy them online or if you buy them at the door. The question is, what is that number of tickets? So I've set up two variables, C, which is the total cost of tickets, and T, which is the number of tickets. All right, so for our first scenario, it's going to be $10 per ticket plus $8. And for our second one, it's just going to be $12 per ticket. And so once again, $10 per ticket plus the $8 service fee, $12 per ticket. All right, now that I've got these set up, I need to draw a graph and see what happens. So what I need to do is set up a table of values to plot these two equations. And I'm going to show you the table that I made for the first equation, and we're going to plot it, and then we're going to plot the second one, okay? All right, so I'm going to pause here and slide in my table. All right, I set up with my table as the x value would be equivalent to the t. T is going to be the independent variable. It's going to be on the x-axis because the number of tickets I buy is going to determine the total cost, and that's going to be y. And that's why I wrote an x here above the t and a y above the c, and our ordered pairs, of course, are x and y. So I did it for three scenarios, buying 2 tickets, 4 tickets, and 6 tickets. And if I buy 2 tickets, 10 multiplied by 2 plus 8 would be 28, when x, or in this case, t is 2, c would be 28, or y. And I did that for 4. That's how I got my 48. 10 multiplied by 4 plus 8 would be 48. If I buy 4 tickets, my total cost is $48. If I buy 6 tickets, my total cost, 10 multiplied by 6 plus 8 would be 68. 6 tickets is $68. And the reason I did this table of values before I did anything else is now I can figure out what my axes look like. What should the intervals be? And that really helped me. Okay, so I'm going to show you, pause here for a minute and show you my second table of values, and that's going to be the one where C equals 12t. All right, here's my second table. Sorry, it's a little messy. I made a mistake and I had to correct it. In this case, I've got t, 12t, and c because our equation was c equals 12t. And if I buy 2 tickets, 12 multiplied by 2 would be 24, so I plot the points 2, 24. If I bought 4 tickets, 12 multiplied by 4 would be 48. I plot the point 4, 48. And if I bought 6 tickets, 12 multiplied by 6 is 72. I plot the point 6, 72. Now, you might already have the answer for this, and I'm going to tell you why, because you may have already noticed that one of these sets of points was in our first equation. But let's put them on a graph, and let's see what that point is. And here is my graph. On my vertical axis, I have C, the cost of the tickets, and on my horizontal, I have T, the number of tickets. And the name of the graph is the cost of tickets, and I plotted the points. In red, you see the equation 12t. I plotted the points from our table, which I will bring back in a moment. And in black, I have the equation 10t plus 8. And the point where they meet is pretty much right here. I apologize, once again, my graphing is just a bit off. But as you can see, 448 would be the intersection of both of these lines. And that's the solution set. And that solution, by the way, was also in our table. And I'm going to bring our table back. And here it is. You can't see them both at once, or perhaps you can. Let's see. Oh, yeah, there you go. So that was my table. And I want you to notice something. You can see that the point 448 is here, and 448 is here. So if you were paying attention, if you notice that, you could see that you actually could find the point where they would intersect before you graphed. But in this case, you were required to graph, and that's why we went ahead and made one. All right.